Ever wondered what secrets are hiding in the shadows of giants? When we think of Saturn, our minds immediately jump to its magnificent rings or its largest moon, Titan, with its thick Earth-like atmosphere. But orbiting just beyond the limelight is another world, a place of mystery and intrigue that challenges our understanding of how celestial bodies work. This is the story of Rhea, Saturn's second-largest moon, and the baffling discovery of an atmosphere that, by all accounts, shouldn't even be there. For centuries, Rhea was just a tiny, distant point of light. It was first spotted back in 1672 by the Italian astronomer Giovanni Domenico Cassini, the same scientist who discovered the famous gap in Saturn's rings. For over 300 years, that's pretty much all we knew. It was one of Saturn's many moons, a frozen, quiet sphere of ice and rock. We assumed it was just another dead world, geologically inactive and silent. But the universe, as it often does, had a surprise waiting for us. Fast forward to the modern era of space exploration. The Cassini-Huygens mission, a joint venture between NASA, the European Space Agency, and the Italian Space Agency, arrived at Saturn in 2004. This incredible spacecraft was designed to spend years studying the gas giant and its complex system of rings and moons. While Titan and Enceladus often grabbed the headlines, Cassini also paid close attention to Rhea during its many flybys, and in 2010, it found something completely unexpected. As Cassini swooped past Rhea, its instruments detected the faint, almost imperceptible signature of a gas cloud surrounding the moon. It was an atmosphere. Now, when I say atmosphere, don't picture blue skies or fluffy white clouds. Rhea's atmosphere is incredibly tenuous, meaning it's extremely thin. To give you some perspective, the concentration of oxygen in Rhea's atmosphere is about 5 trillion times less dense than what we breathe here on Earth at sea level. If you were to stand on Rhea's surface, you wouldn't feel a breeze or be able to breathe. In fact, you probably wouldn't even notice it was there at all. The pressure is so low, it's practically a vacuum. But the sheer existence of this atmosphere is what makes it so astounding. Rhea is a small, icy body with very weak gravity. According to our classic models, any gas released on its surface should quickly escape into space. It simply doesn't have the gravitational pull to hold onto an atmosphere for any significant amount of time. So, what was Cassini detecting? The spacecraft's instruments confirmed the presence of two main components, oxygen and carbon dioxide. This wasn't just some random puff of gas. It was a consistent, albeit flimsy, atmospheric layer. This discovery sent planetary scientists scrambling for an explanation. Where was this oxygen and carbon dioxide coming from, and how was it being replenished? If it can't hold on to gas for long, there must be a constant source producing it. This is where the story gets really interesting. The leading theory points to a process called sputtering. Rhea, like many of Saturn's moons, is constantly bombarded by energetic particles. These particles are trapped and accelerated by Saturn's powerful magnetic field, the magnetosphere. When these high-energy ions slam into Rhea's icy surface, they act like tiny cosmic. This energetic bombardment has enough force to knock water ice molecules apart, breaking them down into their fundamental components, hydrogen and oxygen. The lighter hydrogen atoms quickly escape Rhea's weak gravity and drift off into space. The heavier oxygen molecules, however, linger just a little bit longer, forming the thin oxygen atmosphere that Cassini detected. This process would create a continuous, albeit very slow, production line for oxygen. It's not breathing air, but it's an atmosphere born from the interaction between a planet's magnetic field and its moon's icy surface. The carbon dioxide is a bit more of a puzzle. It could be that carbon-rich materials, perhaps from cometary impacts or trapped within the ice itself, are also being broken down by this radiation. Or, it could hint at something deeper. Beyond its ghost-like atmosphere, Rhea is a fascinating world in its own right. It's a heavily cratered ball of ice, suggesting its surface is ancient and has been battered by impacts for billions of years. But it's not just a uniform landscape. Cassini's images revealed spectacular, wispy, white streaks across its surface. For a while, scientists thought these might be a sign of cryovolcanism, ice volcanoes erupting water and other materials from the interior. However, closer inspection showed that these wisps are actually massive cliffs and canyons, some towering hundreds of meters high. These are tectonic features, suggesting that Rhea's crust has been stretched and fractured at some point in its history, revealing fresh, bright ice underneath. This leads to even more questions about what's going on inside Rhea. Is its core rock or ice? Is there a possibility of a subsurface ocean, similar to what we suspect on Europa or in Lotus? The data suggests Rhea is mostly water ice, but its density indicates it must have a rocky core. Some models even propose that this core might be undifferentiated, meaning the rock and ice never fully separated into a distinct core and mantle. This internal structure could have major implications for its geological history and its ability to generate heat. The mystery of Rhea's thin atmosphere forces us to rethink our assumptions about where we can find atmospheres in the solar system. We used to think you needed a large, massive body like Earth, Venus, or Titan to hold on to a significant gaseous envelope. But Rhea, along with other icy moons like Jupiter's Europa and Ganymede, which also have tenuous oxygen atmospheres, shows us that's not the whole story. Atmospheres can be created and sustained through dynamic processes, even on small, cold worlds. This discovery highlights just how active and interconnected the Saturnian system is. Rhea isn't just an isolated moon. It's an active participant in its environment. It's shaped by Saturn's magnetic field, and in turn, it contributes its own tiny bit of material back into the space around Saturn. It is a beautiful example of the complex dance of physics and chemistry that plays out across our solar system. So, while Rhea may not have the dramatic plumes of Enceladus or the thick, nitrogen-rich air of Titan, it holds its own unique place in the celestial hall of fame. It's a world that keeps us guessing, a world with an impossible atmosphere that is slowly giving up its secrets. It reminds us that even in the most seemingly barren corners of space, there are active, dynamic processes at play, waiting to be discovered. The universe is full of these quiet surprises, and Rhea is one of its most elegant. Thank you so much for joining me on this journey to one of Saturn's most enigmatic moons. If you enjoyed this deep dive into the mysteries of our solar system, don't forget to hit that like button and subscribe for more space explorations. Let me know in the comments what cosmic curiosity you'd like to explore next. Thanks for watching.